Welcome to the Agentic AI podcast. Look, if your job involves deploying AI in really high-stakes areas, finance, critical infrastructure, complex supply chains, you already know the toughest part isn't just getting an answer. It's proving why that answer is correct.
Right.
Your systems, they absolutely demand reasoning that's reliable, transparent, and crucially scalable. You just can't base a major regulatory decision or a huge financial move on some kind of opaque black box.
Exactly, and that absolute need for transparency. That's really why chains of thought, or katotai, became such a big deal initially.
Right.
It's this prompting technique basically forces the LLM to break down the problem, show its work step by step. That started moving complex tasks like risk modeling out of that totally opaque zone. It sort of mimics how we deliberate.
Yeah, making it auditable.
Which significantly boosts accuracy and, as you said, auditability. Super important.
But, and this is a big but, Kate came with this pretty massive cost attached. All that thinking aloud, all those steps laid out. Computationally, it's expensive.
Oh, very expensive. High token usage, definitely.
Yeah, high tokens, big latency issues, and it really drags down scalability. Which is why, for any CTO trying to scale their AI now, the real pivot is towards something called metacognitive reuse.
Metacognitive reuse, yeah.
Yeah.
It's really the next step in how these agents evolve. It's the AI's ability to look back at its own successful reasoning from the past.
Okay.
Distill that thought process, that successful pattern, and then adapt it, reuse it efficiently for new tasks. It tackles that efficiency and consistency problem head on, the one that standard Coty kind of created.
So our mission today really is to unpack how this approach takes LLMs from being these static, kind of wordy responders to becoming genuinely adaptive, self-improving agents, which is what makes enterprise automation not just reliable, but finally, potentially cost-effective when you scale it up. Let's dig into that.
Okay, so to really get why this reuse thing is a breakthrough, maybe let's just quickly revisit how Coty works, the mechanics. It's basically a strategy where the model writes down its thought process before it gives you the final answer.
Right, like for a problem that needs several logical steps or math steps.
Exactly. So think about calculating the combined risk profile for two companies merging based on maybe a dozen financial metrics. A standard model might just spit out high risk.
Yeah, the black box answer.
Precisely. But with Coty, the model would list it out. Step 1, calculate the combined debt-to-equity ratio. Step 2, adjust for regulatory differences in their operating regions, and all that detail. It lets an auditor say, actually check the logic at each stage.
And it works, right? I mean, we've seen Coty give pretty big performance lifts, like, what was it, up to 40% accuracy gains on benchmarks like GSM-8K, that's the grade school math test one.
That's right, significant gains, because it forces more careful reasoning.
And that transparency, like we said, it's just non-negotiable for big decisions, risk assessment, supply chain moves, you name it. But here's the problem again. In those massive high-volume enterprise systems, all those detailed reasoning steps mean enormous token counts.
Huge.
If every single AI agent is rederiving basic logic millions of times a day, well, scaling becomes incredibly slow and expensive. So you've got this tension. You need the transparency, but you can't afford the cost at scale.
That's the exact tension, yes. And it's precisely why metacognitive reuse is becoming so critical. The LLM doesn't just run a successful Coty process and stop.
Right.
It reflects on that process. It looks at the trace, identifies the patterns, the parts of the reasoning that keep coming up, and abstracts them, turns them into reusable pieces.
Okay, so the system is kind of writing its own internal cheat sheet, distilling its successful moves into these little modular instructions.
You could put it that way. Yeah, it creates what some researchers actually call a behavior handbook. It's like a storage place or repository for these efficient, abstracted reasoning patterns.
A behavior handbook, I like that.
So when a new similar problem comes along, the model checks the handbook first. It asks, is there an optimized, pre-approved behavior here that fits, instead of, wasting tokens, generating the whole thought process from zero every single time.
Let's make that concrete.
Yeah.
Like the algebra example from the research we looked at. If an AI is constantly solving different optimization problems, and it keeps needing to, say, factor a quadratic equation.
Right, a common step.
It doesn't rederive the logic of how to factor a quadratic every single time. It abstracts that whole chunk of reasoning into a named behavior. Maybe it calls it quadratic factorization.
Exactly.
And then it just calls that behavior with a quick low-token hint instead of spelling out the whole factorization process.
It massively cuts down the computational work. Think about a human expert. An economist doesn't reread the textbook definition of supply and demand for every single problem they solve.
No, they just apply the principle.
They apply the established principle instantly. The AI is learning to do the same thing. It's turning these slow, expensive, step-by-step derivations into quick, almost procedural memory recall.
That makes total sense for efficiency. But here's a question. If the agent is always leaning on these optimized, stored shortcuts, does it risk losing its ability to tackle genuinely new problems? Situations where the answer isn't in the handbook and it needs fresh, creative reasoning.
That's a great point, and that's where the metacognitive part is really important. It's not static. The process is dynamic.
Okay.
If the agent checks the handbook and none of the existing behaviors work or they lead to a wrong answer, it's forced back to doing a full, detailed chain of thought derivation from scratch.
So it defaults back to the slow way if needed.
Exactly. And here's the kicker. If that new detailed derivation is successful, then that novel reasoning process itself gets analyzed, abstracted, validated, and potentially added to the handbook.
So it continuously improves its own cheat sheet.
Precisely. It's self-improving adaptation. The handbook grows, becoming more comprehensive over time based on new successful reasoning. And look, this ability to abstract reasoning, it's not just theory. There's serious research driving this. Meta AI, for instance, did foundational work with their metacognitive reuse paper. They actually showed you could extract these specific named behaviors, things like systematic counting.
Right. And for you listening, especially if you're managing AI budgets, this is where the numbers get, frankly, pretty stunning. Let's quote those results from Meta AI's tests. On tough datasets like math and AIM, these test really high-level math and algorithms.
Yeah, challenging stuff.
They demonstrated up to a 46% reduction in tokens. 46%.
Yeah.
While, and this is key, maintaining or sometimes even improving the accuracy.
Just pause on that for a second. The operational impact. You're nearly halving your inference costs.
Yeah.
While potentially making the system more reliable. It's significant. And beyond that, look at Meta's specific architecture they built called Meta R1.
Okay, what's special about that?
It's basically this clever two-level system. You have an object-level model that just focuses on doing the task, the execution, and then you have a meta-level model sitting above it whose job is to regulate, to optimize the process, deciding when to use a store behavior versus when to think from scratch.
Like a manager overseeing the worker model and the results from that system.
Again, really impressive. On that GSM-8K benchmark we mentioned earlier, the Meta R1 setup got 27.3% better performance
Better answers.
and 32.7% token savings. Wow. Simultaneously, it's a massive double win. Higher quality results, lower infrastructure burn.
Wow. Okay, so how does this reuse actually happen under the hood? What are the mechanisms?
Well, there are a few core technical methods making this possible. First one is reasoning caches.
Cache, okay, like temporary storage?
Kind of. They store specific intermediate results or states within a long chain of thought sequence. So if the process gets interrupted or if part of the reasoning sequence repeats later, the agent can just pull that saved state from the cache instantly. Avoids recomputing everything up to that point.
Makes sense. Faster, more fault tolerant. What about using smaller models? I think I saw something about that.
Right. That's reasoning distillation. This is really interesting. You use your huge, super capable, but very expensive foundation model to generate those high-quality reasoning traces, the gold standard behaviors.
Okay, the expensive model does the heavy lifting up front.
Exactly. Then you take those abstracted behaviors, the distilled logic, and you use that to fine-tune a much smaller, much cheaper model for actual deployment.
So you're transferring the smarts from the big brain to the efficient worker drone.
You got it. You bake the genius logic into the practical model. Makes deployment way more cost-effective.
Clever. And the last piece was about long-term memory.
Yeah, memory-augmented models. This gets into using external memory systems, often things like vector databases, to store these abstracted concepts, the behavior handbook, persistently for genuine lifelong learning.
So it's not just in-session caching, it's durable knowledge.
Right. Frameworks like ArcMemo are exploring this. Agents can draw on this external long-term logic pool. They can access concepts or behaviors they mastered weeks or even months ago. That ensures real consistency over long periods.
Okay, so this capacity for reuse, for reflection, it really does shift the game for enterprise AI agents, doesn't it? We're moving beyond just, chatbot assistance and into tackling serious business needs like speed, cost, and crucially, auditability.
Absolutely. Let's talk concrete use cases. Think about compliance and regulatory environments. This is potentially a game changer.
How so?
Well, reuse COTI means you get consistent audit trails. Every time a decision is made, maybe it's a know your customer check or ensuring a trade follows policy, you can guarantee it followed the exact same pre-vetted, approved reasoning pattern every single time. That consistency is gold for regulators.
I see that. Total nightmare if every agent reasons slightly differently on compliance checks. Okay, what about operational benefits? Customer support.
Big potential there, too. Imagine support agents, or rather the AI assisting them, reusing stored successful troubleshooting patterns. They can resolve complex customer issues much faster. Some of the research suggests this could cut response times by maybe up to 30%.
30% faster resolution.
Yeah.
That translates directly to happier customers and lower support costs.
Directly. And in finance, metacognitive reuse is already helping with fraud detection. The AI reuses stored, validated reasoning about how known fraud schemes typically unfold.
So it applies those learned patterns to new transactions.
Right. And it can flag suspicious activity with higher precision, meaning fewer false alarms bothering legitimate customers. Then there's healthcare improving diagnostic reliability by ensuring consistent, validated logic is applied when analyzing complex patient symptoms.
Okay, let's boil it down for the decision maker listening. The pitch seems to be, you get higher accuracy, potentially seeing boosts like that 10-27% range.
Improve performance.
You get significant cost savings, 15% to maybe even 46% token reductions. Huge.
Lower operational expenses,
Yeah.
definitely.
You guarantee transparency because the reused logic is inherently auditable.
Critical for governance.
And
Yeah.
you can potentially fine-tune and adapt models faster for new domains just by injecting the relevant behavior handbook.
Faster deployment and specialization, yes. It's a compelling package. But, as we get excited about rolling this out into critical systems, we absolutely have to keep a balanced perspective. We need to look at the risks, too. Reusing intelligence like this, huge rewards, yes, but it definitely comes with some serious potential downsides.
Okay, let's talk trade-offs. What's the biggest systemic risk you see when you centralize reasoning into this behavior handbook?
I think the most significant one has to be the risk of error propagation.
Meaning,
If the reasoning pattern that gets abstracted and stored in that handbook is flawed, maybe it's subtly biased or just plain incorrect, then reusing that flawed pattern means you amplify that error instantly across the entire system every time that behavior is called. Imagine a risk model develops a tiny wrong assumption about a certain market segment. If that gets baked into a reusable behavior,
every single future decision related to that segment inherits the same mistake.
exactly. A localized flaw becomes a widespread systemic problem very quickly.
That sounds like a major governance headache.
Yeah.
We talked about saving tokens, but what about just managing these potentially massive handbooks, the storage, the compliance?
Yeah, the storage overhead is a real factor. Maintaining these large behavior libraries or external memories isn't free. It has to be part of the TCO calculation. But even more critical is the data privacy angle.
How so?
Well, what if the original reasoning trace, the one being abstracted, contains sensitive customer data?
Right.
When you abstract and store that logic long term, you have to be incredibly careful that the process fully complies with regulations like GDPR. You can't accidentally persist sensitive info in your reusable logic patterns. Secure handling is paramount.
So the governance focus kind of shifts, doesn't it?
Yeah.
It's not just about validating the output of one AI query anymore. Now you have to validate the integrity of the stored behaviors themselves. How do companies even ensure that abstracted logic, that golden path, is actually correct and unbiased before it gets reused potentially millions of times?
It really demands a whole new layer of validation, almost like a meta-level review process that specifically audits the behavior handbook itself, not just individual task outputs.
Auditing the auditors, kind of?
Sort of, yeah.
Yeah.
It means rigorous testing methods designed to find flaws or biases in the stored logic. You need robust processes to ensure ethical reuse and actively manage that risk of amplifying bias. That oversight layer is absolutely essential to prevent a small error snowballing into a massive systemic failure or regulatory breach.
Okay, so let's try and pull this all together.
Yeah.
Metacognitive reuse.
Oh.
It isn't just some minor technical tweak.
Yeah.
It feels like it fundamentally transforms LLMs. They go from being these static, often Paisley tools into genuinely adaptive, self-reflecting agents. And that seems to be the critical enabler for building AI workflows in the enterprise that are compliant, cost-effective, and actually robust enough for high-stakes work.
I think that's exactly right. This
Yeah.
technology points directly towards a future of more autonomous systems. You look at frameworks like Meta R1, they're demonstrating systems that can dynamically improve themselves, regulate their own reasoning strategies. We're definitely moving beyond just simple task execution
Towards what?
towards true autonomous planning, complex adaptation. Think about coordinating intricate global supply chains or managing dynamic financial portfolios. And really, the critical question for you, listening now, probably isn't if this technology is viable. It clearly is.
The question is,
The question is, how quickly can your organization build the necessary governance framework around it? How fast can you start strategically integrating reasoning reuse into your own agentic AI workflows? Because the potential gains in cost savings and reliability, they're sitting right there waiting to be unlocked. That's the challenge to consider today.